Hello everyone, welcome to another session of Code with your friend. So today it'll be a different session. So far we have been exploring the Qt-hash library in C. It's actually a collection of header files and we were exploring how to use utilist. We will revisit that in some time. We have explored one set of macros which are like single linked list macros. But today we are going to do a very lightweight stream because it's already evening and I'm streaming after work, so my brain is not up to the same speed. So what I decided is just use this time to let's learn Rust. So I think that's the objective of the stream that I have is I know nothing about Rust and I'll try to start learning about it and capture it. So all the learnings in Rust that we do, um, I'll try to put them under a single playlist and also try to share the code that I have with everyone. So if you want to check out the code, you can also do that. So the first thing that we want to do when we learn a new language is basically just go to the official homepage. So we are the doc rustlang.org. And the first thing that we also want to do is install and create a setup so that we can compile, run, debug our code and create some code, run the samples that they have, and then possibly try to write some of our own code and let's see how that goes. So let's see how basically we can install Rust in our setup. Let me go outside of this and it's still under exploration. Um, Actually, it's under tools, so probably I'll go to tools and the languages and maybe just under language exploration I'll create another exploration directory. Cool. What do we have here? The version of the text assumes you're using Rust 1.65 or later. See the installation section to install or update Rust. Let's go to the installation section. Installing Rust on Linux or Mac OS. So I'm using an Ubuntu WSL. I hope it'll be similar to the Linux installation here. Let's try that. Oops. Oops. Okay, I think I copied. Downloading installer. Default installation should be fine. Downloading components. Cargo, Clippy, Rust docs, Rust STD. Rust is installed now. Great. To get started, you may need to restart your current shell. This would reload your path environment variable to include the cargo's bin directory. To configure your current shell, run source home cargo environment. I can restart my shell. I think my shell is restarted. So how should I check? On macOS, yeah, I should run maybe Rust C version. Okay, so we got Rust. Yay! So we got the first steps done. Cool. You should see the version number, commit hash, commit date for the latest stable version that has been released in the following format. Rust C XYZ. Okay, yeah, that's I think what we are seeing here essentially. If you see this information, you have installed Rust successfully. If you don't see this information, check that you have. Okay, I think we can skip this part. Updating and uninstalling, we don't want to go into that now. So now let's go to the hello world. So just to better work on this, probably I'll create it on the side and then bring this on the left side. Um, do I have NeoVim here? Okay, cool. So I have NeoVim here. So I can try to do some initial editing in the command lines and maybe shift to VS Code later. Okay. We can do like a project hello world. Okay, that is fine. I want to create a file name. Yeah, main.rs. Function main print ln bang hello world. It's pretty neat. And how do I compile it? We just compile rust c main.rs. What does it give us? It gives us a main executable. So I should run it and it shows me. Sorry. Main.rs. Let's say the CMind. So it looks println. It looks. We took the inspiration from Java, print line option. The good part is we also add new line without me saying add a new line. That's pretty good. Println bang. So why do I need that exclamation mark after that? I still don't know. Possibly we could arrive at that at some point. Anyway, anatomy of a Rust program. This is beautiful. So let's review this hello world program in detail. Here's the first piece of the puzzle, function main. These lines define a function named main. Got it. So it's pretty standard of our C-like languages. The body of the main function holds this code. This line does all the work in the little program, prints text to the screen. There are four important details. Rust style is to indent with four spaces, not a tab. Okay. And second, we have a println, which calls a Rust macro. If it had called a function instead, it would be entered as println. Okay, yeah, that's I think the question that I have. Why do we need the exclamation mark? That actually calls a Rust macro. I don't know what a Rust macro is. Is it a C macro? We'll see. We'll discuss Rust macros in more detail in chapter 19. Okay, so we have a long way to go. For now, you just need to know that using an exclamation mark means you're using calling a macro instead of a function, and that macros don't always follow the same rules as functions. Fine. You see the hello world string, we pass the string as an argument to println, and then string is printed to the screen. And fourth, we end the line with a semicolon, which indicates that the expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. That is perfect because it's better. We have a delimiter for a line. Compiling and running are separate steps. You just run a newly created program. So let's examine each step. Compilation is this. If you have a C++ diagram, you'll notice it's similar to GCC or Clang. That's right. And on Linux, Windows, we have this main thing, and then Linux, Mac OS, you'll see two files. PowerShell on Windows, you'll see the same three files with C, exe, pdb, and rs. This shows the source code file with .rs extension, the executable file main.exe, and main on other platforms. And when using Windows, a file containing the debugging information with the pdb extension. From here, you run the guard. That is quite good information, I think, to get. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead-of-line compiled language, meaning you can compile a program and give the executable to someone else and they can run it even without having Rust installed. If you give someone a Ruby, Python, JS file, they need to have a Ruby, Python, JavaScript implementation installed respectively. Got it. Okay. That is because those are interpreted languages, right? It's not right to Rust is an ahead of time compiled language, meaning you can compile a program and just give the executable to someone else, which makes sense and they can run it even without having. This is similar to I think because it's a systems programming language. It should be if you give a okay. It's I think a unique way to compare with another language, but I think Rust, to my understanding, which is very minimal, is not similar to Ruby, Python, or JavaScript, which are interpreted languages, which means they basically get converted to another language and then they get executed. If I'm correct, let's see the definition of interpreted language. Interpreter. In computer science, an interpreter is a computer program that directly executes instructions written in programming or scripting language without requiring them previously have been compiled into a machine language program. An interpreter generally uses one of the following strategies: parse the source code, translate the source code into some intermediate representation or object code, and explicitly execute stored precompiled bytecode made by a compiler and match the interpreter virtual machine. Um, so I guess like my point was is Python an interpreted language? Dynamically typed, garbage collected, support, structural, um, multi-paradigm, object-oriented, procedural, functional, structured, reflective. Okay. Let's ask Google, is Python interpreted or compiled? Python is an interpreted language. It's Science Direct. Should I trust it? It's not a property of the language, but a property of the implementation. For most languages, most, if not all, implementations fall in one category. So one might have few words saying the language is interpreted or compiled too, but it's still an important distinction, both because it aids understanding and because there are quite a few languages with usable implementation of both kinds, mostly in realm of functional languages. I'm not going into the functional language domain yet. In addition, there are C interpreters and projects that attempt to compile a subset of Python to C or C++ and subsequently to machine code. Compilation is not restricted to ahead-of-time compilation to native machine code. A compiler is more generally a program that converts a program into one programming language to another. A lot of talk. So, but to stop nitpicking and answer the question you meant was practically Python is compiled, not compiled to machine code ahead of time. That is compiled by the restricted and wrong, but alas, communication only compiled to bytecode. But it's still a compilation with at least some of the benefits. For example, a statement. Got it. It's similar the way Java is, right? Because Java also gets compiled to bytecode. Uh, so compiled to machine code is a different thing. But the other examples that I mentioned, okay, so we directly went to Ruby's homepage. Um, I think Ruby is an interpreted language, right? Developers calling Ruby can make some interpreted language like Python rather than compile one like C, C++. So that's what Oracle mentions. But anyway, I think we are sort of diverting away. But my point was like this is not a right comparison to make because Rust should be compared with systems programming languages like C, C++, which directly gets compiled to machine code and does not have like an intermediate state. Uh, so anyway, hello cargo. Okay, so cargo is probably I should increase the font a little. Build system package manager. Rustaceans use this tool to manage their Rust projects because Cargo handles a lot of tasks for you. Building your code, downloading the libraries, and building those libraries. We call the libraries your code needs, dependencies. The simplest Rust programs, like the one we have written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of the Cargo that handles building your code. As you write more complex Rust programs, you'll have dependencies. And if you start project using Cargo, adding dependencies will be much easier to do. Because the vast majority of the Rust projects, do I already have Cargo? Shouldn't be. Okay, it's already there. So creating a new project with Cargo. Okay, Cargo, new, hello, Cargo. Created binary application, hello cargo package. What other things do we have? So we have a folder, then we have a TOML file, and in source we have main.rs. Probably I need to open VS Code now. Cool. So this shows package name, version, edition 2021. Okay. Even though we're in 2023 and we got good syntax highlighting. What do we want to do? And it has also initialized a new Git repository. Oh, is it? With a gitignore file, Git files won't be generated if you run a cargo new with an existing Git repository. Okay. The file is in TOML, Tom's obvious minimal language format, which is Cargo's configuration format. What is this? Config file format for human. Okay. It has got useful native types, key value pairs, arrays, tables, inline tables, arrays of tables, integer floats, boolean states, times. File is supported. Okay, Tom's obvious minimal language friends. Okay, I think it's a configuration rather than XML and stuff. It's using that, which is cool. The first line is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add more sections. Cargo has generated a hello world program. Source files to live inside the source directory, building and running. Okay, so now I think we can sort of run it from here. Okay. Okay. There is no remote repository yet, but we can still see a Git repository is initialized, which is cool. So how do we build it? We just do a cargo build, compiling, and it generates a tons of stuff. So, okay, hello cargo. I think that's what we want to run, right? Then target, debug, hello cargo. Okay. If all goes well, hello world should print to the terminal. Running cargo build for the first time also process cargo to create a new file at the top level cargo lock. This file keeps track of the exact versions dependencies in your project. Okay. This file keeps track of the project doesn't have dependencies, so the file is a bit sparse. Don't ever need to change the file manually. Cargo manages its contents for you. This file is automatically generated by Cargo. It is not intended for manual editing. Fine. We just built a project with cargo build 5, cargo build and ran it with target this. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use cargo run. Right, makes sense. Finish dev unoptimized debug for targets and there's running. Cool. Provides a command called cargo check. This command quickly checks your code. Cargo checking. And make sure it compiles but doesn't produce an executable. Okay. So we have learned cargo build, cargo check, cargo run. Why would you not want to execute? Often cargo check is much faster than cargo build because it skips the step to produce an executable if you're continually checking your work while writing code. Using cargo check will speed up the process of letting you know that project is still compiling. Many recipients use cargo check to realize the right program to make sure it compiles, then they run cargo build when they're ready to use the executable. Let's recap what we learned. So create a new project with cargo new, then we build an executable with cargo build, cargo run is to run it, cargo check if we don't want to produce the binary. Instead of having the result of the build in the same directory of the code, cargo stores in the target debug directory. Makes sense. When your project is finally ready for release, you can use cargo build ---- release to compile it with optimizations. This command will cargo build ---- release. So now we should have debug directory and release directory, and there we have hello cargo. Cargo is a convention. With simple projects, Cargo doesn't provide a lot of value over just using Rust C. Exactly. But it'll prove its worth as your program becomes more intricate. Once programs grow to multiple files and dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you will use in the rest of your Rust career. Okay. In fact, to work on any existing projects, you use the following commands. So check out the code using git, change to that project's directory, and then build git clone, citizen project, and the cargo build. Okay, that's I think the standard workflow that the Rust folks or the Rustaceans want to follow. You just go there and do a cargo build. Again, check out the documentation. Got it. Install the latest version of Rust using rustup. Let's try rustup once. Rust toolchain installer flags plus toolchain subcommand show rustup update. Cool. Okay, so now we are into hardcore coding. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. Makes sense? You will learn about let, match, methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more detail. This is a nice way. So we'll just practice the fundamentals. We'll implement the classic beginner programming problem, a guessing game. It'll generate a random integer between 1 and 100. It'll then prompt the player to enter a guess. After a guess is entered, it'll indicate whether it is too high or low. Otherwise, okay, makes sense. So let's actually go to the Rust directory and say new project cargo new guessing game. The first command is new. Okay. So the file name is there, cargo run. Now I think we want to this is actually hello. So we can open the source code here. Guessing game main.rs. Okay, so here we start using stdio function main println main guess the number. Again we do println. Please input your guess. Let is string io std in read underscore line address of not. Yes, I don't know if it's address of a not. I just because it's a C convention. Expect equal to line. Print line. You guessed. Guess. So we'll do a target check here. So, okay. Looks fine, right? The IO library comes from the standard library. So stdio is our standard library. Rust has a set of items defined in the standard library that it brings into the scope of every program. This set is called the prelude, and you can see everything in the standard library documentation. I think we won't go into that now. If a type you want to use isn't in the prelude, you have to bring the type into scope explicitly with the use statement. Using the stdio library provides you with a number of useful features: ability to accept user input. Function main is the enter point, guess the number. So let's see if we do cargo run. We already have a guess, is it? So it'll just do that. Okay, it's just a string. So we'll just read the line and then we say, you guessed what? Storing. So this is a variable. So what does this mut means? The let statement create a variable. Use similar example. This line creates a new variable named apples. It binds it to the value 5, and Rust variables are immutable by default, which is amazing. Meaning once we give the variable a value, the value won't change. This is, I think, something I personally like a lot. This, in the long run, this helps in providing thread safety, uh, because mutability is the main issue of thread. Um, what should I call it? Any kind of um, race conditions. So if you don't have mutable states, that becomes much easier. So if you want to be mutable, you have to be explicit about it. You can still be mutable, so you have to just say I'm mutable. This is like a comments syntax, which is fine. So this is standard. The equal sign tells Rust we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of the string. String is a type provided by the standard library that is growable. You give it encoded bit of text, the colon syntax, and this new line indicates that new is an associated function of the string type. An associated function is a function that is implemented on a type, in this case string. This new function creates a new empty string. You will find a new function many types because it's a common name for a function. Okay, got it. Okay, so new is a function. An associated function is a function that's implemented on a type. In this case, string. Okay, so new is an associated function. It creates a new empty string. You will find new function many types because it's a common name. So the same function is associated with many different types, but it produces different objects, should I say? I don't know. Instances, perhaps, a better way to tell it. In full, the let me this has created a mutable variable that is currently bound to a new empty instance of a string few. Okay. Receiving the user input. So we use this VIO and we have the IO module which allows us to handle user input. If we hadn't imported the IO library with use stdio at the beginning of the program, we could still use the function where the function call is stdio stdin. Okay. But yeah, I think it's similar. Like every time we have to provide like it's kind of a namespace thing that we have in C++. The stdin function returns an instance of stdio stdin. Um, Here std is in capital, okay, which is a type that represents a handle to the standard input for your terminal. This calls the readline method on the standard input line. We're also passing mutable guess as the arguments to readline to tell it what string to store the user input in. The full job of readline is to take whatever the user types into standard input and append into a string without overriding its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. The ampersand indicates that this argument is a reference which gives you a way to let multiple parts of your code access one piece of data without needing a copy of the data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of these details to finish the program, but now all you need to know is like that. Like variables, references are immutable by default, hence you need to write ampersand mutable guess rather than ampersand guess to make it mutable. Okay, so we're making it a reference. Probably we need to understand more about this reference part. So reference is the Java concept, right? So you have like a reference to an object, but this is machine code. So we have reference to memory. Okay. Handling potential failure with result, we're still working on this line of code. We're now discussing a third line of text. This is, I think, we could have written this code as IOSDN, readline this, expect, yeah. Okay, it's easier to read. readline puts whatever the user enters into the string we pass to it. It also returns a result value, and the result is an enumeration, often called an enum, which is a type that can be in one of the multiple possible states. We call each possible state a variant. Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and error. The OK variant indicates operation was successful. The inside OK is a successfully generated value. Error variant means the operation failed and the error contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. Hold on. So who is okay? So readline returns a result object. Got it. And results variants are OK and error. The OK variant indicates that the operation was successful. Error indicates the operation failed. Expect method we can call on result. If this is an error value, expect will cause the program to crash. If the readline method returns an error, you would like to resolve the error command line operating system. If this instance of result is an OK value, expect will take an OK. If you don't call expect, the program will compile, but you will get a warning. Okay, so essentially, what is this doing? It's like saying we are not handling the error. Let's see. Compiling. Oh, it's okay. It's attached. Okay, so warning. So okay, this is really cool. This result may be an error variant which should be handled. Unused must used on by default. Okay. So if it's an error variant, we should expect some way to handle it. I don't know if this is sort of what the different ways we could handle it, but anyway, printing values with println placeholders. Okay, now I think this is interesting. Placeholders. So we don't need a formatting kind of thing for C++. It prints the string that now contains the user's input. The curly brace is a placeholder. This is a little crab pincers that hold the value in place when printing the value of a variable. The variable name can go inside the curly brace when printing the result of evaluating expression. Place empty curly brackets in the format string and follow the format string with a comma separated list of expressions. Printing a variable and the result of an expression in one called println would look like um, this. So YAMLs, okay, y plus 2. Interesting. And the result of an expression in one called println. Okay, nice. So testing, I think this is actually work, generating a secret number. Now we need to generate a secret number that the user will try to guess. How would we create that? Rusty provides a rand create with the said functionality. So now we come into the question of adding a dependency. So using a crate to get more functionality. So a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code that is intended to be used in other programs and can't be executed on its own. Cargo's coordination of external crates is where cargo really shines. Before we can write code that uses rand, we need to modify the cargo TOML file to include the rand crates as a dependency. Open that file now and add the following line to the bottom. So let's go to the cargo.toml file. So we want to have dependency. We need to know. Okay, this is I think on us to know the version. External crates. Cargo understands semantic versioning, which is a standard for writing version numbers. Shorthand for which means that version is at least 0.85 but below 0.9.0. Cargo considers these versions to have public APIs compatible with version 0.85. The simplification ensures that you will get the latest patch release when you will compile with the code in the chapter. Any version 0.90 or greater is not guaranteed to have the same API as what the following examples use. Now, without changing any code, let's build the project. Cargo build, updating the crates IO index. Interesting. So ideally it should download a bunch of things. It should download rand, it should download libc, get random, cfgf, ppv lite, rand chacha, rand core. Okay, yeah, I think this is. So you may see different version numbers, but they will all be compatible with the code thanks to semantic versioning, different lines. Okay. When we include an external dependency, Cargo fetches the latest versions of everything the dependency needs from the registry, which is a copy of the data from crates IO. This is the Rust community's crate registry. Instantly publisher creates and install them, use the API to interact and find out more information about available crates. Become a contributor and enhance the site to your work. Interesting. Package manager for Rust. After updating the registry, Cargo checks the dependency section and downloads any crates listed that aren't already downloaded. In this case, although we have listed graph. As a dependency, Cargo also grabbed other crates that rand depends on to work. After downloading crates, Rust compiles them and compiles for dependency. So where does it provide? So the dependencies are here. This one will be there. So I think this is where the dependencies are built. Okay. Anyway, Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies you specified until you indicate otherwise. For example, say that the next week version 0.8.6 of the rand crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates a cargo log file the first time you run cargo build. So now we have the missing directory. Updating a crate. So we can do cargo update. Okay, there is nothing to update. Should I just try to update this one here? Fail to select version for the requirement. This candidate versions are maximum 0.85. Okay. Fine, I think we are deviating too much from the main language. I just want to like write some code in the core language. This is all about the like the packaging system, the crates and stuff, building projects. This is too much outside, right? I mean, these are all important stuff, but first we need to learn the language, right? Uh, use rand RNG. Okay. And what are we going to do here? So we want to let the secret number be rand colon thread range string range 100 and no, we don't want to print the secret number. Please input your guess. Okay, okay. I think from now we can print secret number cargo bill. Oh, I have to fix this. Cargo run. So the secret number is 83, and I also entered 83. Now I think the explanation part. I think the explanation we can skip. We sort of got it. The rand ranges. And I mean, the one thing that I would like to know is how do I know which API to use? For example, rand is it should be there in GitHub somewhere. API reference. Yeah, I think that's something that I need is how do I know which function to call? Um, there's a book for Rand, or is it just called book? I don't know. Just a web page maybe. So Rand range, and then we have thread range. Thread range, thread local generator. And then gen range is we have to provide. So I think, yeah, API reference master branch, API reference docs.rust, same thing. First one book, versions. Um, yeah, I guess like the best way would have been to see a file. For example, like in C header files or a Java header file where we can see all the functions, right? Like what are the functions that are available. Mm, Probably the GitHub page would have an API. Tutorials, something like that. If I'm able to sort of read that code, what is defined, then I'll feel more confident. Right now, it seems too tricky. So, where is this capital RNG is being used? So, thread range. So, I'm using this rand. what if I don't have this, right? Uh, so this will cause an error because for struct thread range in the current scope. Uh, so should we then just define it as thread range? Why are we using generic? Is it like a generic range or does thread range exist? It doesn't, right? Because consider importing unresolved import. So ranges, thread range, still doesn't work. Unused import, okay, unused import. So it's saying no method name genRange found was struct in the current scope. So how would I resolve it? If I say I come up with this code, does it say how to resolve the method? Use ran.rng. The following trait is implemented but not in scope. Perhaps add a use for it. So it's a trait, right? I think we Rust traits. Defining shared behavior. So at least this is good. I heard like the Rust compiler is quite good. It actually tells you a lot of these things. You can also try out this. What is this? Rust C --6 E0599. What is this? This error occurs when a method is used on a type which doesn't implement it. For example, you have struct mouth, then let x is equal to mouth, x.chocolate. So no method named chocolate found for type mouth. In this case, you need to implement the chocolate method to fix the error. So mouth should implement the chocolate. Self, we implement the chocolate method here. I love chocolate. Now it's okay. As far as my understanding goes, what I know about traits, so you can assign a certain set of properties through trait, right? So ran.rng should be a trait, not dot, colon. It should be a trait, right? It's a trait. And so the genRange is a function. So it's kind of an interface that you need to have in that scope. Otherwise, you can't call genRange. That's I think my understanding, but it's too early to say if that's correct. Anyway, so you won't just know which traits to use and which methods and functions to call from a crate. Yeah, let's understand. I think what is this guy saying? We are adding two lines in the middle. The range trait defines methods that the random number generators implement, and this trait must be in scope for us to use those methods. And chapter 10 will cover traits. Yeah, so it has all the set of methods. We are adding two lines in the middle. In the first line, we call the rand thread range function that gives us the particular random number generator. We are going to use one that is local to the current thread of execution and is seeded by the operating system. Then we call the genRange method on the random number generator. The method is defined by the range trait that we
brought into scope with the use rand range statement. The genRange method takes a range expression as an argument and generates a random number in the range. That kind of range expression we are using here takes the form start, end, and is inclusive of lower bounds. Cool. Go ahead. Okay. This I particularly like this cool section. Like even if you don't have, you're just exploring on your own, right? Like you can learn a lot of things just by this explain things. Can I just try out like random explain? It's not a, oh, it should be a valid error code. Um, what are the Rust error codes? Error codes index, right? Cool, so many error codes. So let's just explain 0001. What's happening here? This error code is no longer emitted by the compiler. Suggests that the expression arm corresponding to the noted pattern will never be reached for all possible values of the expression being matched. It's not arms. Match block has too many arms. Some bar X, this handles the none case. All possible cases have been handled. Okay. Cool. What is this? This error indicates that an empty match expression is invalid. This is amazing. So you have tons of error code. This is beautiful. This is I like. I mean, um, I don't know if it's possible to exhaustively capture all different kinds of errors, but since it's a deterministic language, um, you might know what are the possible ways the different features will be accessed. So cool. Let's try this. Cargo doc minus open. What is this doing? It's doing documenting. Couldn't open the docs command. WSL view did not execute successfully. Okay, so okay. Oh shit! It created like a HTML doc for it. Trace, okay, another neat function that running will build documentation provided for locally and open in your browser. Okay, I think because I guess the WSL did not work, that is I think fine. Cargo run. Comparing the guess to the serial number, whatever this code does not compile. Okay. Um, so comparing the guess to a secret number. Now that we have the user input and the random number, we can compare them. This step is shown in listing 2.4. Just here as we will explain file name source main Rust, use rand range, compare stdio function main snip println, too small, too big. Let's then try probably. But why won't it handle anyway? Um, but what's the type of the secret number? Can we get type of in Rust? Rust the type of a variable, right? How do I do that? Is there any valid way data types? I think I'm skipping ahead. Expect not number, scalar types, 8-bit, 16-bit data, okay. First we add another use statement bringing a type code. Let's do that. Let's see if that works. Unused import. Okay, that is fine. After println, you guessed. Expected struct string found integer. Aha. Okay. What if so basically it's trying to compare between string and integer, so that is fine. At least I am able to understand that much. Um, Standard comparison, ordering into scope of the standard library. Then we add 5 new lines at the bottom. Compare method of two values can be called on anything. Returns a variant of the ordering enum we brought into scope with the use statement to use a match expression to decide what to do next based on which variant of ordering was returned from the call. The match expression is made up of arms. An arm contains a pattern to match against. The code that should be run if the value fits. Looks to the patterns match constructs trust features. Walk through the example. So I think the main point is the comparison itself is wrong. When the code compares 50 and 30, compare the ordering parameter. Yeah, the core of that states is mismatched types. Rust still was able to infer that the guess was should be a string, didn't make us try the types. It should number other than a number type. Um, 32 or 32-bit number, 64-bit number as well as others, unless otherwise I default try 32, which what if we just do this, right? I don't think it'll also compile, so there is no new associated with I32. So what do we do? Um, okay. So instead, we just convert it to and oops. So this remains same. After that, you just call it here. Let guess u32 match guess dot trim parse. Okay, none, none, error, continue. You guessed guess, got it. Um, what about now? Continue outside of a loop. Hold on. Let's explore. Break outside of the loop. Loop keyword. So in case of error, should we just handle them? Let's say call handled. Expected user retrieve found string. So okay. So let's say we just give it 0. That actually works. Okay. If I just do cargo run, secret number is this 88. It's too big. It will just go out. So I think the loop part is missing. I think we have to implement the loop part. There is a loop implementation, which we are skipping. The string parse, and it should just say expect please input and integer. Where are you using it? In that case, no, this is not a match. What about okay. Thread name panicked. Please input an integer percent error. Okay. So okay, now I think this is fine. We are able to create a variable. It does. Hopefully Rust. I think the loop part is not there. I think it's not a guessing game yet. We bind this new variable to the expression getString parse. The guess expression refers to the original guess variable that contained the input as a string. The trim method on a string instance will eliminate any white space in the beginning and the end, which must be done. The user must enter read line. Okay. Anyway, convert a string to another type. Here we use it to convert from string to a number. I think if we don't have a trim, then it will also fail, right? Even by entering proper number, it fails because by default enters a new line. Okay. Lonely word with characters that can logically be converted into numbers and so can easily cause errors. For example, the string contained. Okay, parse method handling potential failures with result. This is there now. Yeah, I guess the loop part. So now I think the loop thing will be there. So the entire thing, please input your guess, should be wrapped up in within a loop. This entire stuff should go inside. Um, but it's still not breaking, right? So we have to break. So I have to just somehow. But you will notice entering any non. Yeah. So quitting after agreeing. So
this we can handle it here. I think this makes sense. So within this match expression, we can call a break. Probably just move it here. Please input your guess. 15, 5, 11. You win. Cool. So I think this is quite nice. Cargo run. Awesome. With the one final trick, we'll finish the guessing game. What did the last change happen? Okay, yeah. So even here, yeah. What happens if we just do this? We just expect this, right? So instead, so that's why I think the last time it was not matching. So we can just do let guess u32 match guess trim bars. Okay, num error continue. So oh, um, so this actually handles the error case. We'll just um, I don't know. I mean, to be really honest, I think maybe we can print something similar. What I'm thinking is um, we can say println invalid input. That will be better, right? Okay. Semicolon. Not a function. Yeah, I know. Okay. So this is actually makes better because now you have invalid input and you continue. So okay, this is I think the first change that I suggested, which the tutorial didn't have. So seems good. So we are slowly getting the hang of how to write code in Rust. So one final tweak. What is the tweak? Let's delete the println that outputs the secret number. Of course, yeah. If you know that, then the fun is lost. Now I think uh, it's a proper game. So we have a secret number already there. Let's say 15. Too small. So what about 75? Too big. What about 50? Too big. What about 30? Too small. 40? Too small. 45? Too small. 47? Too big. We win. So it's typically like standard binary search. Exactly, it's just do binary search. So we'll do 50. Too small. 75. You win. So 50. Too big. 25. Too small. 37. Too small. What's the middle of that? Um, 30. It's around 43. Too big. 40. Too small. 41. 42. Okay, so I think this is like, yeah, this is I think a standard binary search. So I think that's enough for today. Um, I guess we can push it in our repo.
Um, Probably we can create like a, I believe at the top level we can just do here, maybe we can create a get push kind of thing. Um, Silver parakeet. Just exploration. Um, just create. Oh. Hopefully, um, get and get and dot. Oh, wow. No commits yet. Guessing game doesn't have a commit checked out. Okay. Okay. That's fine. But should I need to do that for cool? Get commit push local Rust exploratory code get branch minus main get remote and origin get push minus u origin main. Cool. So now we have the code in GitHub if you're interested. So that's, I think, it for today's session. We'll again, in the next session, we'll try to learn some more Rust, or maybe we'll do something else. We'll see. Bye bye.